I've got this lunar tilt thing's like baffling me at the moment. It's like, part of me says, okay, that maybe that is what actually happens in the winter months, but also part of me is thinking, well, maybe it isn't. So what I've done here is I've got, that's like England, yeah, and that's America. Okay, so just make them land masses like that, and then you've got Europe, and yeah. Now I'm in London, which is here, so we'll say I'm there on that point, right? Now, if from London, so I'll face London like that. If from London, the moon's here, I can see half of it in black, right? The moon spins, I'm not sure if it spins clockwise or anti-clockwise. That's the one thing I'm going to have to answer the question to. I don't know if it spins anti-clockwise, but we spin clockwise, don't we? No, we spin that way, don't we? Yeah? So, if the moon is in a fixed point here and the moon's going that way as well, remember we're leaning back at the moment because it's winter. Yeah, so hold on. Let's get this. So, that's where I am in England and we're leaning back, and from that I can see the moon like that, right? Well, the moon drags behind, I think. When this starts to move into a different angle, it will appear from the ground that the moon's doing that as you go around the rotation. Because think about it, right? And I might be completely wrong, but logic's saying to me, because from in the winter, right, England's further away from the sun. So if you think the sun's there, so we're tilted away, and we're still rotating on that axis there, yeah. So this point is dipping. We're the rotation that's pointing away, right? So if this body's in the sky that's fixed, as we dip to point and move away, it'll seem like the moon's doing that. Yeah? Because we're here, and like as I say, we're dipped away. In the summer, we're more here. So we rotate like that, so it'd look like a twist the other way, really, yeah? But in the winter, we're like this. So it's turning like that, as it is, right? And this fixed point, I don't know how it rotates around the Earth, whether it rotates the other way or whatever it does. This would stay the same. This would stay the same like that, right? But as we move down, can you see I'm going down on an angle? It will appear like the moon's doing that because of the way we rotate in a three-dimensional state. I'm going to have to observe it myself. What I'm going to do is set up a time-lapse camera, and see if I can work it out. But yeah, anyone would like to? Anyone got any? It's difficult because as the observer, it's all to do with the rotation of us. Because sometimes when you take a long time frame of the North and South Pole, you get that sort of twisty motion as if the stars are like moving. Yeah. Now someone says the stars are in the wrong place, which is quite interesting because if they're not in the right place, they don't get me that they move each year, but they only move slightly. They should still be grouped in a certain group. Like Orion is usually, for me, over there somewhere. Comes up and then goes around like that, and out throughout the year, the year it'll go that way, and then till the summer, where, because I don't know where Orion is, it must be up here somewhere, because we tilt back forward. It's out of our trajectory whenever we spin. We don't see it. It's always in the daylight. So yeah, I'm going to observe that, but that's quite odd. But just if that's dropping away from, yeah, it would look like that's rotating. If you look at it from an eye point of view, it's very, very difficult for me to. All right, so the moon's like that. We're now dropping away. So as I drop away, it would look like the moon's doing that as you go down. Yeah? Do you get me? Because of the spin down, it's us that's causing the rotation. I think. Yeah, I think it's us that's causing the rotation. I've never actually looked at the moon and took any notice of whether it rotates. I suppose I've looked at it more in the summer than in the winter. But I'll keep my eyes out. I'm going to have a look. I'm going to put a time-lapse video up to try and catch it in action. And then basically we need someone with a solar system. Someone needs to be able to create the Earth with the moon in the right place. We need a 3D person who can create a 3D environment and put these two things in place, and then do a view from a point on this rotational ball, if you get me. Because we do that, don't we? And then we go around the sun as well. There's a whole movements all over the place. And of course we're tilted that way one year, that way the other year, depending on where we are. And that tilts 15 degrees. So if you go to this far, it's 15 degrees that way as well, isn't it? So it's 30 degrees. But that would happen as well, which would probably make the moon look like it was higher and lower. So that, by its tilt, controls its height, and because it's a bit higher anyway. So if we're tilted forward, it'll look like it's higher in the sky. And if we're tilted backwards, it'll look like it's lower in the sky, and which it does at the moment. Okay, and then that stays as a fixed point and rotates with the Earth. But because the Earth moves down and this still stays high, it looks like it's doing that. Yes, it makes logical sense to me. I might be wrong. Anyone's thoughts, please. Thank you, peace, love and light.